This is the Art of Network Engineering podcast. In this podcast, we'll explore tools, technologies, and talented people. We aim to bring you information that will expand your skill sets and toolbox and share the stories of fellow network engineers. Welcome to the Art of Network Engineering. I am AJ Murray at No Blinky Blinky. And joining me tonight, Lexie at Track It Pacer. Lexie, how you doing?
I'm doing fantastic, AJ. I've had a great day, some stimulating conversation. I've been feasting on the knowledge base of Twitter all day long.
I saw
asked
that.
a question about Ethernet, and oh my God. It's been amazing.
Isn't that cool where you can like put something out like that and get like not only responses, period, but you get good responses?
Yes, that's exactly what I was going to say. It feels almost like sacrilegious that I can just like scream into the void about like the Ethernet standard, and like the people who wrote the Ethernet standard will respond to my fucking tweet. It's bonkers. It feels like I shouldn't be able to like summon all the CCIEs in the world who are like on Twitter just by like sending out a stupid tweet, which by the way, I didn't even word properly. But I sure did that. And it's been great. Like I'm learning so much. I can't even believe. So I've had a great day.
That's awesome. That's awesome. I had a similar experience in the Discord this past week. So I am doing the data center design course on CPT Nuggets, and Jeff Kish teaches that. And I watch a nugget, I had a question, and I can go into the Discord and I can like talk directly to Jeff Kish about like something that he was talking about. And I'm like, but wait, Jeff, what does this mean?
That's awesome.
And then
it's
like he like, you know, we get into it a little bit, just like a discussion on the topic. And I'm just like, you know, it's not lost on me that I can watch you in a video, have a question, come here and talk to you. Like I feel, you know, like this is really cool. So that was fun.
Awesome.
And then there's Andy at Andy Laptef. Andy, how you doing?
I'm awesome. I spent way too much time fighting in Linux today. I want to go on record as saying I don't like Linux. I don't know if anybody likes Linux.
Oh,
I feel like the programming people like Linux. People who are like software people, like, I love Linux. Like, how can you like Linux? Anyway, but I learned some cool stuff. I'm trying to install some software on a server, and there's no virtualization on the server. So I have to install it in the shell. I've never done that before. Yeah. And I'd be curious what your thoughts are maybe some other time. But like I'm fighting for like, we need some virtualization here. This is silly why we're just installing it right on the, like, I don't know why we're doing that.
I guess it depends on what you're going to do with it. There's certainly reasons not to do virtualization.
Really?
Oh yeah. Yeah, there's just some things that need direct access.
So maybe sometime in the future, when we talk about data center design, maybe we could talk about, you know, instances where you would not want to virtualize in a data center. That would be, we'll have to write that one down. I'm going to write that one down.
All right.
But yeah, I had to edit, what is it called? VI? I don't even know. I'm like Linux.
Yeah.
VI, huh?
They were showing me VI, and you go in and you edit the stuff, and X to delete something, and I to insert, and I edited my first. Is it a Linux file? I don't even know. I don't know. Well, that's a long answer. I'm sorry. I spent a lot of time in Linux, and I'm still recovering from it.
I'm curious. Like, what are you doing? Like, what you doing? What you up to in Linux world?
I am trying to install NMS, open source NMS software so that I can play around with some telemetry.
Okay.
And I went in the Discord. I got some recommendations. And, you know, again, every time in prod or at home, I've messed with installing software on a server. There's a type 1 hypervisor running on bare metal. I get it, you know, whatever, OVA, or I forget what it's called, but you get the image, you throw it in there, and you assign your cores and your RAM, and you're done. I'm just in Linux hell of like, oh, you know, Etsy this and go in there and you got to do that and enable this service. And then, you know, oh, you need your SQL database. Like, oh my God, like it just, but I'm learning, which is great.
Yeah.
You know, but I'm really just trying to get some NMS software running on a Linux box.
Which flavor
I'm having a hell of a
time
time
playing with?
CentOS. Is that what you mean?
Well, that was a follow-up question of mine. Yes. So you're doing CentOS, and what are you doing for the NMS?
Zabbix. Is that what it's
okay.
called?
Yeah. Zabbix.
Yeah.
Yeah.
But I've heard that it's tough to set up compared to other ones, like Network Pistolero was telling me that. Like, this other one's a lot easier, but, go ahead, man. Good luck.
I'm curious as to why you guys aren't virtualizing that.
Yeah, so we're having good discussions, right? Like I'm on this team, my buddy Chris, my boss, they're in there, they're helping me, we're banging it out. And then we're having those discussions because I want to virtualize it because I'm more comfortable in that environment.
Oh, sure.
But sometimes it's good to be uncomfortable, and I'm being forced in the Linux shell, learning Linux that people have been telling me for years I need to learn, right? So
even if you were virtualizing it, like I think that Zabbix has an appliance, like a already pre-formatted virtual machine that you could put in there, but you could also just spin up a raw virtual machine and install Linux and then install Zabbix on top of that.
Do all this. It just seems like so much lifting to just install software. That's all. It just seems like so much. And maybe if I was a Linux guru, it wouldn't be a big deal. But I'm learning, and that's fine, right? Like all these certs we take, and like when you're learning, it's difficult. It stinks. You complain about it, but then you learn something, and you're like, hey, look, now I know this thing. So
yeah.
Very long. That might be my longest answer to how you doing, Andy, on the show. So I apologize to the listeners.
I'm glad I asked.
That's what I've been doing today. But it was a good day. I learned a bunch of stuff, and I really love the people I'm working with. So it's nice.
Good.
Yeah.
That's awesome.
What about you, AJ?
Yeah.
I'm good. I'm real good. Work's going well. A little bit of a lull this week, which has allowed me to do a little bit more studying than usual, which is fine. I'm just waiting on other people, right? Like a new project started up. We're waiting for the customer to send us over some configs. I am also waiting on our staging team. So my previous VAR or partner that I worked at, I staged the gear. I bootstrapped the switches and installed the OS. But now here at the new company that I work for, if you order something with us, unless you're adamant about having it shipped directly to you, we will have it shipped to a warehouse. We have several warehouses around the country, and we have a team of staging engineers that will rack and stack the gear per the cable diagrams that I send it. They will upgrade to whatever flavor of OS that myself and the customer decide we're going to deploy, and then I can provision the gear remotely using an out-of-band management system and do all sorts of testing and make sure that it is completely good to go before we ship it out to the customer, which I just think is the coolest thing in the world.
That is really cool.
So they'll install the optics for you, right? And you can get the code upgraded, and that's nice.
Yep. I mean, that's all stuff that I used to have to do, and now I don't have to do it. So like literally now I can just worry about being an engineer.
You used to do like the physical stuff as well?
Oh yeah, like I would have to like plan. If I was going to go on site, I had to like give myself an extra day because I had to do the rack and stack and I had to do the software upgrades and all that stuff. But now I don't have to do that. How do
you like it not having to do that anymore?
It's different. I won't say that I like to do like software upgrades because some of that stuff is boring as heck. But I mean, like right now we're working on an ACI fabric project and I want to do the rack and stack. Like I want to play with the gear, but I'm not going to go all the way down to the warehouse and do that. It's not like it's right next door. That's for sure.
Dang. Interesting switcheroo there.
Yeah. Yeah. I mean, some gear, like if it's gear that I haven't touched or played with before, like, heck yeah, I want to play with it. I want to rack it. I want to put the line cards in. I want to do all that stuff. But if it's just like whatever vanilla switches, don't really care.
You just reminded me when I used to work in the city in an office with a bunch of people in there. ASR 1002Xs were our bread and butter in the WAN. So I used to have them on my desk. And man, when you plug those babies in, it's like a jet engine taking off.
Oh, yeah.
The whole office would stand up and look over the dividers like, what is happening? I'm like, sorry, I got to, upgrade the code and get some base config before I ship it. But it was so loud. Like, you do not turn them on in an office environment with people trying to work.
No.
I mean, I did. At your desk. But maybe that's why they sent me home, to be remote.
They have all the routers shipped to your house.
Whatever works, man.
Right?
Yeah.
And now it's time for some wins. Winning in our Discord channel this week is Adam Pawlowski, starting a new role as a network engineer. Congratulations.
Yeah.
ELIGRP passed the CompTIA Project Plus.
I like that username.
Yeah, right. Here's a good one. John Capiobanco is starting a new position at Cisco as a developer advocate. Congratulations, John. And Cisco.
John, they're lucky to have him. That's awesome.
Yeah. Daniel Dibb passed his AWS Advanced Networking Specialty. Congratulations.
Nice.
Steel Network passed the Cisco DevNet Associate. Nick Fournette passed the CompTIA A+.
Nice.
I like this username, King Doss. So this is an interesting story. He caught COVID, had to go on a 2-week quarantine, and used that time to study for the JNCIA Junos and passed it.
I just had his username in my head. You remember Run DMC? I am the king of DOS. There is none higher. Suck at MCs. Or maybe that's nice. Beastie Boys. I think it was. Anyway, sorry.
That's great. I love it. Luke Bibby, Certified Terraform Associate. Jonathan Switch, Employee of the Year at their business or at their work. Congratulations. Nice. Jay Fizzle passed the JNCIA, and they posted it in October in the general channel, and it turns out his wife was listening to the podcast to hear his win get announced, and so he posted it this week, and so we just want to say congratulations, Jay Fizzle, and we hope your wife hears this.
Oh, shizzle.
Dalton B passed the CCNA. Congratulations, Dalton.
Big one.
Hemo 200 passed the Fortinet NSE 1 and 2. Congratulations. Nice. Error Disabled passed the Aviatrix Professional Certification. Man, he has just been knocking those Aviatrix ones out like left and right. I feel like it wasn't that long ago. It's just announcing the associate level one, and now he's already doing the professional.
Killing it.
Tim McConaughey starts a new position at Aviatrix this week. Congratulations.
Good job, Tim.
And this has got to be my favorite win, maybe of all time. Manny accepted a new position as a network engineer, and he'll be working at Insights Global with Mike V2. So
very cool. Congrats.
It's so cool to see that come out of the community.
So
New
cool.
Patreons joining us this week, Chandler Bassett and Peter Evans. Thank you so much for your support of what we do here at the Art of Network Engineering. There are so many ways that you can show support of the show. You can like, rate, review our podcast wherever you find it. Subscribe to us on YouTube. Smash that bell icon. You get notified of all our future content. Like the videos you're watching and comment. All that stuff is really good mojo for the social media platforms there. So also make sure you're following us on Twitter. You can find links to all of our socials at the bottom of the show notes or the show description. Make sure you check out our merch store at artofneteng.com/store. Every bit of profit we get from that store, we put back into our community. And of course, the Patreon program. Cisco IT Blog Awards. Voting is still open for another few days. You can vote for us and your favorite network engineer content creators until the 18th of February. So make sure you hit the link in the description in the show notes and go vote for your favorite ones.
I'm going to vote for you.
And I'm going to vote for you. And then I'm
don't
going to
vote for me. Vote for the podcast. Yeah, vote for the podcast, and I'll vote for you.
What's great is that you can vote for more than one. You can vote for like 5, and then you can rate like 1, 2, 3, 4, 5, like what you think. Yeah.
All right.
Yeah.
So I'll vote for the podcast. I'll vote for you, and I'll vote for me. Cool.
Yeah, there we go.
I thought it was a one thing. All right. Awesome.
Oh no, not this time.
Cool.
And this is the last time I'm going to ask on the listener survey. We're still looking for responses in the listener survey. We've gotten almost 100. We'd love a few more. So if you have some time, please take a few minutes and complete our survey. All of that information we share with potential future sponsors, and it really helps us guide where the show is going to go in the future. And I am so excited to announce that we are going to do our very first Art of Network Engineering live event coming up in April. It'll be April 9th from 4 to 7 at Highwire Brewing in Asheville, North Carolina. We're going to put a link in the show notes. You can check out. Go ahead, Andy Screamer. We'll put a link in the show notes and in the description if you're watching this on YouTube, and you can get some general information on the event. And in early March, we will have a registration page. We'll be able to provide tickets. It's absolutely free, not a paid event, but it is going to be a ticketed event because there is a limited number of people we can have. I think it's like 50 or 60, something like that. But and all thanks to our sponsor, Open Gear, for their support and helping us put together that event. Thank you so much.
So what are we going to do there? What are we doing there? It's going to be a show?
Yeah, it's going to be a live show. We're going to meet and greet with some of our favorite fans. We're going to record a show so everybody there can be a part of that. Little Q&A, interactions. It's going to be an awful lot of fun.
Yeah, maybe we'll give something away. Maybe there'll be some merch.
Absolutely.
I don't know. Yeah. I'm really excited. It became real yesterday when I booked my flight.
And we're on the same
really
flight.
Excited.
I'm really excited about that.
we're seat buddies back and forth to and from.
So we hope you can join us at our first live event coming up here in April. Now back to the show. Well, on that note, tonight we are going to talk about data center design. We are continuing the series, the design series. We've already talked a little bit about enterprise design in a previous episode. And I was hoping to talk about, data center design, and then we can contrast a little bit between what are we doing in enterprise versus the data center. I don't think we did this on purpose because when we planned the topic schedule, I hadn't yet decided to embark on my data center design journey. But I have been recently studying for it, so I feel particularly primed to discuss it, but not like super deep.
Me tonight.
Well, you're like our resident design guy, right? Like you've studied design, yeah?
I've studied network design for a while. Like I have worked in some pretty nasty networks, and they are nasty because there was no design to it. There was no planning. It was just, we need more ports. Let's put a switch over here, or whatever. And it was just, it was dirty. Like there was so much latency in the building that you could be on VPN and have a better connection to the servers. Like that's how bad it was.
Yikes.
I guess if you don't know any better, right? Like you could just keep daisy chaining switches forever.
And that's what I've seen people do.
Yeah. But then there's I forget from CCNA, but there's like not a circumference, there's a hop of like, you shouldn't go past a certain amount. Cause then like what doesn't work? Does it mess up spanning tree? I forget.
There's like a diameter.
That's what I was trying to think of. Yeah. Like you because then you'll run into problems, I guess, right?
Well,
like
the diameter should be equal on both sides. Like if you're at the core and you're going to daisy chain switches, if you have to, they should be the same. It should be equidistant. But if it's lopsided, it's just, the whole thing's going to be weird.
So what should you do? Home run each switch back to where you're running them to? Where's
back to either the core. Like if you're doing a collapse core model, you're probably going to home run all the switches back to a core or like an MDF that has a distribution block in it.
Right. So before we get too deep, should we should we
let's
get
start more basics?
So we're in the weeds already, right? So this is data center design, and I was even thinking today, walking around the house, thinking about tonight, like we should probably define a data center, right? Because I don't even know. I've managed data centers, I've worked in data centers, and I'm not even sure I have a great definition. When family asks me like what I do or like where I work, they'll be like, it's a big room full of fancy computers. Well, what do the computers do? Well, when you go on Facebook or Instagram, that those things live on these fancy computers. Like, you try to dumb it down.
People actually ask you those questions, Andy. No one ever cares enough to ask me anything.
My dad, who is listening, he's listened to every episode. He's been trying to figure out what Dad. I do for a living. Yeah, hi, Dad. Aww. He's been trying to figure out what I do for a living all this time. Because, if you don't work in tech, it's magic, right? Like,
it's just so nice that he wants to find out, because most people I talk to, unless they're in tech, in which they don't ask anyway because they already know, right? Like what it is. Most people don't. No one really asks me.
Yeah, my dad's the man.
Sorry, that ended up really sad sounding. I did not mean for it to be like that.
And the show took a turn.
No one loves me. No one cares.
Well, honestly, you're right. Most people don't ask me. My wife doesn't want to know, doesn't care. Just make the Chromecast work. You know what I mean? And you're right. Like most people don't. Most people don't want to know.
Make the Chromecast work. Yeah.
But so how would you decide? I mean, let's define a data center, right? Like, why do data centers exist? They say everything in tech solved a problem. So like, have data centers always been around since networks started? I don't think so.
I don't know if they've been around. Oh, well, I mean, mainframe days, the mainframes were probably.
Yeah, they probably have been, right? Because you had to have a place when computers were first starting out, like to be a
massive.
thing in general. They were so big, you had to have like a dedicated room.
If you wanted like a 4 megabyte disk, you had to like move it in on a pallet. So
I believe, I could be wrong. I believe the first computer was at the University of Penn in Philly. It was called the ENIAC, I think. And it was like a couple city blocks long. So I almost wonder if that was the first official data center. Ooh. Like it's a building that houses computer stuff. There's cooling, there's power. I don't know. Have we defined data center yet?
Well, you want to get really far back.
I think it's in the name, right? Like there's data there, right? And you store all of your applications and data for a business or for an organization. Now, a lot of that, particularly with cloud, the data centers are becoming decentralized, right? Like the data centers used to be the main focal point. Everything would connect through the data center and then out to the internet, from there, or the internet connection would come into the data center and then you would break it out to all your locations. Well, with SD-WAN, with cloud, it's becoming very decentralized, but if your organization still runs applications on premises or has their own homegrown applications, or, they're definitely going to have data like customer data and stuff like that. Not to say that you can't run it in the cloud, but data centers still exist. They're still a thing. And that's what happens in the data center. That's where all your applications are. That's where all your data lives, all your compute to operate all of those things. So that's loosely what's in the data center.
When you can sit at home on your computer and go somewhere on the internet, or if you're at a business or an office or a bank or whatever, like when you're on a computing device going somewhere, that request is going to wind up probably at a server in a data center somewhere.
Even the cloud, it's just somebody else's data center.
Yeah,
somebody else's
that's where your cat
hardware.
Pictures live, in a data center. And I have a cute little data center story. When I got my first job, like when I got my fintech job, the guy's walking me through the data center down in the city in Philly. And I'd never been in a data center and my jaw was on the floor and I'm like, oh my God, this is amazing. And I turned to the guy giving me the tour and I'm like, who's responsible for all this stuff, man? And he looks at me with disgust and he takes a beat. He's like, I think it's you, pal.
No.
That was my first day on the job. I'm like, oh, okay. Cause I just never been in one and I was amazed. Like, you have a home lab with a couple routers and switches or, GNS or whatever, man, the first time you walk in a data center, it's pretty intense. I feel like I'm in the future. Like,
it's very loud. It's just like really loud. That's the thing that when my first time, like physically in a data center, I wasn't surprised by really anything except the noise. Cause like TV and movies and stuff, like you eventually see a data center, I feel like. And if you're like, I don't know, I was looking at getting into tech prior to that, obviously. So I had been exposed to it. So I just, you walk in, it's like, all right, this is what it is. It's very loud.
It's all those fans, right? Trying to cool.
All those fans.
Get a cold aisle.
These
you got
big
a
boys,
hot
these
aisle.
big boxes.
Big boys.
Well, that's one of the things that I'm enjoying about the data center design, because we're talking more than just networking, compute, storage, power, cooling, all that stuff.
Oh, like actual facilities design? Is that part of it? That's really cool because I know literally nothing about that other than like boxes need to be cooler all the time.
Right.
That's it. That's all I know.
So much can go wrong, right?
Power draw and like hot cold aisles and things like that.
So I can remember being on projects where there wasn't enough power in the data center to install the stuff we wanted to. So like you would think,
wow,
it's big fancy data center. And the people who manage that, they're like, then there was a whole other project of like, well, we need to add capacity for power. Like, how could you have run out of power? You know what I mean? And then somebody right. And then somebody that we know, I think they had like a cooling issue not too long ago. And that can be, if you have an HVAC problem.
Oh my God.
Things will go south pretty quick. I mean, I guess the worst thing is if your power goes out, right? Well, then you're dead and hopefully you have a backup, like a diesel backup. But I guess it's a slower interesting problem when everything starts to overheat.
At a previous job, we had a couple data centers that like had some weird design that was not okay with the hot, cold. I don't really know how it exactly is supposed to go, but you're supposed to be like pushing hot air out a certain direction that's consistent throughout the aisles. And then, like pulling the cold air in from the other way.
But when you order the gear, Lex, you have to like, I think, configure that, right? Like air direction, AJ?
Yeah, like you have
like
to.
You can have it blowing the wrong way.
Physically. Right.
You could be sucking hot air into your gear, I guess, if you don't configure your fans right?
Yeah. And there's a lot of data center gear that has swappable fans. Like, so you can swap the fans out and put the appropriate fans in that will allow it to push or pull the air into the gear. So if you're going to have it mounted at the back of the rack, you want it to pull in from the rear of the device and it exhaust out the front.
So modularity, huh? Mm-hmm. You can redundancy, modularity. Let's get into it.
Right? This just reminds me, because I have like zero data center like experience. I did most of my stuff remotely. I haven't worked with hardware much, but like, I just built my first like PC not that long ago. And like, then I had to replace the fans after that. And it's like, I had to actually, I added a few fans and had to like sort of design it in such a way that it like brings in as much air as possible. And so optimizing that with just building my PC sort of gave me a little bit of like insight into.
I hope you have positive pressure to keep dust out.
Right. Exactly. That's what I was looking for. That's the phrase that I was trying to remember. Yeah. I tried to I looked something up online to do it. I wasn't like figuring this out on my own, but yeah, there's like an ideal way to do it so you're not bringing dust in. And on like a massive scale, you are designing like at least how fans push and pull air.
Yeah.
Right.
So what are you studying now? Like is this a CCDE? Like what are you exactly studying?
So,
is it a cert?
This is, we had talked in a previous episode. I have to renew my CCNP in the next 18 months. It'll expire in July of next year. So there are many different ways that a person can renew their CCNP. I am choosing to do that by getting a second CCNP. And so I'm going to go for my CCNP data center. So I'll have enterprise.
You're not going to chicken out and do the CE credits?
We'll see if I can get close to.
Don't hate on it.
That's a new thing, right? Like you didn't used to be able to do that.
Yeah, you could use CE credits to renew your CCIE previously, but now you can even do it to renew your CCNA.
Right. Okay.
Or your NP, of course. So
your NP is in what?
My current NP is in enterprise. And I did that by doing the Encore exam, the enterprise core, and then the enterprise design exam. And
salad, right?
Yeah, the NSALAD. And so in keeping with that theme, because the CCDE is a goal of mine eventually,
which is the CCIE of design, right?
Yep, design expert.
Yeah. Okay.
Yep. So in keeping with that theme, I decided, when I go do the CCNP data center, I'm going to do the design specialist. So I have that consistency, that design background, because I appreciate design.
Yeah. And I'll be honest, right? Trust tree here moment. Like I've been in organizations that like architects design things and then I either built them and or supported them. So design has always been a weakness of mine in my relatively short, networking career. And even recently I've been learning a lot more about design because I need to in my new role. But I feel like I've kind of done myself a disservice because I just like, well, the architects do that and I don't need to. But here I am, right? Like 9 years into my tech career and I'm still on the show. Like, I don't understand design. AJ, tell me all about it. So, I'm happy now that I'm starting to fill in my gaps a little bit. So where can we start? Do we go old school, like the different designs, like the old, what was it called? Like the 3-tier model?
The 3-tiered model. Yep. There's the 3-tier and the 2-tier. Like, so you'll have your core at the top of the tier. You'll have your distribution in the middle of the tier, and then you'll have your access at the bottom of the tier.
Now, what do each of those do? I've heard the core is the glue, right? It connects everything to everything.
The core connects, one building to another if you're in a campus, right? And then you'll have a distribution block probably within each building, and then access layer switches, throughout the building. So
the access layer switches are wired to the distribution, and that's just aggregating all that access, right?
Right. And then all the distribution
and then the
will connect to the
hits
core.
the cores.
And the core's sole role is to just move traffic as quickly as possible. And so with that in mind...
Between what and what? Between building to building? Like you can have a core in just one building, right?
Right. So the data center can hang off the core. Buildings can hang off of the core. Your WAN will hang off of the core. In its own block, you'll have a bunch of WAN stuff going on, but it connects to the core so it can get that traffic to the rest of your greater network, right?
So real quick, so customer client comes into the WAN from however they do it, MPLS, internet, whatever, but they come in, they hit a router, they hit we're a data center now, right? So like, I don't know if access, so I'm thinking when I was in data center, the access was basically like all the WAN routers that provided services like MPLS.
Oh yeah, sure.
Like it's not enterprise access switches and closets for like PCs. The access is actually similar. Edge routers, right? Similar. Yeah. But what I'm thinking is the customer comes in, they hit that edge router, which we were calling the access. It'll hit the distribution because there's probably routing protocols to tell it how to get to that destination IP it's getting to. It hits the distribution sends it. There's like firewalls in there somewhere, right? I could never see the firewalls in my job. So they're like these magical, like, you'll have to tell me where the firewalls are on all this, but it comes through the distribution, hits the core, goes to a compartment where the application lives, grabs the kitty cat picture, and then the traffic goes back out with the kitty cat picture, right? And then back out to the so that's like that's an oversimplified flow, right? How it comes in, hits all those layers, and then leaves.
Yeah.
Okay.
Yeah, I've been at a service provider that had basically that structure going on. It's just that it was at a much bigger scale. So, customers' servers would be in, for example, one data center in like California, and they would want to grab something from, access their, servers in like India, right? And so, traffic would start at that access layer, go up to the distribution that's still in that same data center where the traffic starts out, and then hits the core, and the core switches it across the world, right? And that's as fast as possible, MPLS or whatever you want to do, and then gets to that data center distribution layer in India, and then hits the access layer again. That was really easy for me to learn it that way, simply because, I don't know, on a bigger scale, it's easier. Whenever I was studying for CCNA, like they do go through that 3-tiered model in the collapse core too as well. And they talk about it in terms like you guys did, like with building to building. And that was a little nebulous for me for some reason. But once I started working at an enterprise or at a service provider that was like global scale, it was easier, I guess, because geographical regions just kind of make more sense or something.
Sure.
I don't know.
Yeah. I can see that.
Yeah.
So that 3-tier model, AJ, was that built for when 80% of traffic was north-south? Like what's that whole like north, south, east, west thing? Because we'll get into that with design, right? Like traditionally before the clients came in northbound, like we just talked about, came in, and then went back out. So the traffic went north-south, meaning, from outside came in and then and went back out that way.
Because in an enterprise network,
like 80%. Go ahead. Sorry.
Yeah. In an enterprise network, your clients typically aren't talking to each other. So there's not a lot of east-west traffic, right? Like you're usually the client wants to go out to the data center or out to the internet to get something. There's generally speaking, not a lot of like communication amongst PCs. Sure, there could be some peer-to-peer stuff, but by and large, and like you say, Andy, 80% of the traffic is going to be northbound out of the network.
And 20 would be east-west. And I just learned this, and I've been doing this a while, so that's why I wanted to point that out. So east-west would be things in the data center talking to each other. Right. Different services, like different
virtual
servers.
Machines, different servers, application servers talking to database servers, things of that nature. There's a whole lot more east-west traffic in the data center.
But it wasn't always that way, right? Like now, I remember reading like 80% was north-south, and 20% was east-west. And I think that's when we did the 3. Correct me if I'm wrong, because you're the you're the design expert. But as I've been studying lately, it shifted from 80% north-south, 20% east-west, and now it's inverted. Now 80% of traffic is east-west in data centers. 20% is north-south, which I thought because all the microservices or whatever they call it in the data center, like you said, servers talking to each other, doing things. And I thought that drove the whole spine leaf architecture, right? Because now you need faster east-west traffic, low latency. You can't have servers waiting to talk to other servers.
Now, is that the idea behind spine leaf? Maybe we are jumping ahead. I always thought that the idea behind spine leaf was like redundancy. If something goes down, it's immediately reachable another link.
Redundancy and scale.
And speed and low latency, right?
Yeah.
Like in spine leaf, can't you get from everywhere to everywhere in like, what is it, like 1 or 2 hops? One hop to anywhere, which server to server, east-west, you need low latency, fast, right? Like it's got to be fast communication. You don't want the traffic spinning around the data center trying to find where to go, I guess.
Then applications and databases do not like latency.
Okay. Like what happens if a database hits latency? It takes a dump.
There's just weird so much happen. Like reading and writing and stuff going on. Like you wouldn't want latency when it comes to databases and all that.
It'd be an unpleasant experience.
For sure. So, boy, we've hopped around an awful lot here. So where do I want to reset back to?
Well, we were a 3-tier.
Three tier.
We were a 3-tier. Well, I think it's all relevant. It's all relevant. Like,
absolutely.
3-tier existed because of north-south being most of the traffic, I thought.
Right.
But there's been a shift to that. I mean, we can go back to 3-tier if we want and break that down a little bit. If you think we should do that.
So with the 3-tier, the core was get data to its destination as fast as possible. So as a result, you're not going to be doing any sort of like ACLs or filtering or anything like that, because that's just going to slow the traffic down. Like that's processing power that the router has to use to check and validate, is the traffic going, should it be going that way, rather than just getting it where it needs to go towards its destination. You'll tend to see more ACLs in the distribution layer because that's where your layer 3 typically lives. Not to say that you can't have routed access layer, but traditionally speaking, your layer 3 is at the distribution block. So all of the gateways for all of your VLANs will typically live in the distribution block. And that's
so your
where
SPIs for VLANs are sitting in the distribution layer, right?
Yep.
They're a gateway to get in and out.
Yep.
Most of the services are at distribution, right? Like quality of service, ACLs. Isn't that where all that stuff lives?
Well, quality of service has to exist all the way down to the access layer.
Oh, everywhere.
Right. Yeah.
Okay.
Yeah.
It has to be access distribution on the access layer. You do have some security things too in the access layer, depending on. But
it's usually layer 2 security. So like ICE. What's the word I'm trying to think of here? Mac layer security. Yeah. .1x. Yeah, .1x. Yep.
Okay.
Yep. So when ICE is going to categorize a device as, this thing versus that thing or whatever, it'll use some sort of layer 2 identification.
I got a firewall question. Can they be anywhere? Because they were transparent to me in my role. I couldn't see them. I didn't know where they were. And if traffic wasn't getting somewhere, we had to get them on because I couldn't see it.
I think typically you'll see them at the edge, but if you have something within your network that you need to secure, there's no reason not to have a firewall more inside the network.
But there's like logical places, like we're talking about design and where your core distribution and access would be and what services live in what. Like, I guess there's similar direction you would take for like where to put your firewalls and what to filter where and right. Like, is that okay? Right.
Yeah. I mean, usually you would have it like at an edge or something like that. Like, that's usually like one of your egress points into the network. Like if you're BGP peering, you might have a BGP router on the edge. And then after your router, you'll have some firewalls. Most of the organizations that I've worked for have been very small. So we didn't do any BGP peering. So our firewall lived right on the edge and we just got like a static address from the ISP.
So your firewall was your edge device?
Yeah.
Yeah. Okay.
Yeah. And I guess that's one of the reasons why I appreciate design, because I've worked for such small organizations where I didn't have an architect. So I had to be the architect and the engineer.
Give you a lot of good experience there.
Yeah.
So much good experience. I don't know when you want to talk about it, but it might be helpful to talk about some poor design, some, like stuff you've seen and the problems it's caused. Like what happens when you don't follow design best practice?
Right. And there's certainly reasons not to. I mean, one of the big things with design is like knowing all the tools that are available to you and then being able to match the technology for the business case, right? Like what are we going to do that's going to support the business and what the business is trying to accomplish?
intimidating part of it to me when thinking about like, I have to design, this architect, like what there's so many technologies and so many products out there. I don't know how anyone even starts. It seems like an architect would already sort of have to start by using things that they already have experience with. Mm-hmm. Otherwise, if you don't know it and you're just like, let's try this, then you're gambling quite a bit. Is that in any way accurate to assume that architects aren't just gonna,
you can do all the research you want and listen to all the pitches in the world, but there's every chance that a product's not going to do what they say it's going to do, right?
There.
So
yeah.
That's why I'm amazed at design. Like you said, you have someone come to you with the problem, like the business, right? Like we have to support the business.
Right.
It's like, what's your business? What are you doing? And like, and I guess there's a litany of questions that go along with that, right? Like, well, how many people are coming in? How much bandwidth do we need? How much, like, do we need redundancy? How many servers? Like, can you give an example of like, when you say we have to support the business and build something that'll work, like what's the business? I mean, are these all software companies, right?
No. So I work for a manufacturing company. It was a global manufacturing company of pumps and motors. And these motors were like the size of my pickup. They weighed tons and they could move enough water in an Olympic-sized swimming pool and empty it in like 3 seconds. I mean, you're talking about like 600,000 gallons moved in a matter of seconds.
So are these for like power plants or something?
Power
like, why are you moving all that water?
Industrial.
Okay.
Like these things would be at SeaWorld or Coca-Cola or,
okay.
Plenty of different other applications for them. Oil rigs,
okay.
Either like pumping oil up from the bottom of the ocean or managing the ballast water on an oil rig.
So this is a manufacturing place that makes those pumps, makes them and sells them.
Yep.
So what do they need with technology, AJ?
Yeah. What are their data center needs?
So when I first started there, this is a great example. When I first started there, they had a 15 meg internet connection. Now, granted, like at the time, that was probably more than enough for what they were doing. They had less than 100 employees. They had all of their applications were in-house. And if they were going out to the internet, it was probably to screw off or to do some market research. And that was about
So their
it.
applications, are we talking like Outlook? Like is this,
email? The email
Exchange
server
servers?
was hosted on servers inside the building. They were using Windows Small Business Server. If you've ever heard of that, it was like Active Directory, SharePoint, and Exchange all in the same box.
So this isn't like proprietary software they built for their customers to order pumps. This is just like running an office, right? Email, internet.
Yeah, and then they had like a file server. They had application servers. Everything was bare metal. They weren't doing virtualization.
Like the old school way, right? You have a server for everything.
Yep.
Yeah.
Exactly.
Okay.
Exactly.
Yeah.
But then, over time, all that hardware got really old, really fast. None of it was supported anymore. It was dying. Application server hard drives were filling up. The internet connection was taking a hit as people were starting to shadow IT. They were doing stuff not telling the IT department, like they were like setting up Dropbox accounts and streaming music and all of this other stuff, right?
So the user experience started getting kludgy, right? Like you can't connect to Exchange when everybody gets there in the morning. It's overwhelmed, or the internet's so slow because everybody's streaming.
And then the network itself was glued together by different manufacturers of like off-brand retail switches, right?
Like Netgear, unmanaged switches everywhere.
Yeah.
That's what we're talking about.
And then like there was no thought put into a network design. Like it was a small building and there was no reason for that stuff not to be home run back to the core, back to the server room. And it was just, you have like the server room and then another switch, and then that would hang off, another switch would hang off of there, and another switch would hang off of that one. And there was no spanning tree. There was one big flat network.
So did they have a core switch when you say the core, or you're just saying where the servers were?
Where the servers were. That was another off-brand.
So how do you go from like that? By you, I mean like you, the person responsible for the network. How do you take that and then like move it in a beneficial direction, right? Like how do you have a good design strategy, but the strategy that's been employed so far has been terrible, and you don't want to take the entire network down. It exists already. Mm-hmm. how do you like reconcile all of that?
You're going to have to take that network down.
To take it down, huh?
You're going to have to swap some hardware. Well, because they don't have a good design, so there's no redundancy, right? So you can't take services down on the A side.
Yeah, I guess what I'm asking really is like, is it hack and slash, like just burn it all down and start over more or less, or is it better to like sort of slowly integrate like better practices until you've retrofitted the entire thing?
It was a lot of retrofit. So we started by moving the server room. We selected.
Quick question: why did you get pulled in initially? Did they call and say, "Oh my God, nothing works. This is awful. Help us"?
Oh, I got hired there to be a network administrator, and then I walked in and I kind of did like. I took a consultative approach, right? Like I interviewed a lot of the managers and I asked them like, what are your pain points with IT? And I looked through everything and was like, okay, this is a fucking mess. So how are we going to fix this?
So there were no network people there. They said, we're going to hire a network person.
There were some people there that did some very IT-like things, but they were not IT people.
Okay. So
and certainly none with an infrastructure background. They were more like application folks than infrastructure. So I was the first infrastructure hire.
I guess because of their growth and because the user experience was degrading. Oh my God, did I just make up a word? So they brought you in to say, please help us. We need to do things here.
Yeah.
Okay. Yeah. Did that scare you? Like walking into a nightmare of a network?
I was excited. I was very excited because like how often it wasn't a startup, right? Like this is a very well-established company. They've been around for a couple hundred years. Now, granted, this was like the US branch of it, but even then that had been around for 30, 40 years.
Couple hundred years. How are they making pumps without electricity 200 years ago?
Well, their original, the original thing wasn't pumps. It was actually toilets.
Right. Different business. Okay. Yeah. We've always needed toilets.
Yeah.
So you were excited in what ways exactly? For what reasons? Like this was a unique opportunity for you, I take it?
It was a unique opportunity. And one of the things that I love to do is empower people through the use of technology, right? Like, if you're doing something the old-fashioned way and it's just not as efficient, I want to show you how you can use technology to, do it better, earn some cycles back, get more done. And I just knew I could see the possibilities because that company was so far behind the times. It's just like, let me show you what we can do here.
Yeah, these people are going to be amazed when I wave my magic wand. Where were you in your career at this point? You had enough experience to know what to do?
I had been working in IT for about 7 or 8 years.
Okay.
And by today, I've been in IT now for 17 years.
Right. But you understood enough about design and how things work to I guess anybody with a modicum of network experience could be like, oh my God, you have unmanaged switches daisy chained everywhere. This is not good.
Right.
Like it's fairly obvious, right?
I certainly have a whole lot more networking knowledge than I did back then. But I knew enough back then to know that what was there was wrong.
Right. So the original question is, what does a bad network design create? Bad user experience, things not working, can't get the stuff, everything's slow, which I guess slows down your whole workforce, right? People are trying to do their job, check email, check on orders, and they just either can't get the things or they got to wait 10 minutes for the Exchange server to give them their mail or something, right? Like as an example.
Right.
Okay.
Because at a certain point, they started to hire a lot more people, and it was more people than that server was rated for, than the server was licensed for. So you have more people firing up their computers all at the same time when they come into work, and they're all trying to check their mail on spinning disks, not like flash or anything like that, over an already impeded network for various reasons. Some switches are... There was like one switch that was a gig that all of these other switches connected to, and that one switch then connected back to the server room over a single link. So the entire company is trying to access everything in the server room over a single link.
So this is a really obvious example, like an answer to that question of like, well, what's the business? What are you talking about? Like a business trying to run everyday operations and their IT infrastructure holding them back, right? Slowing them down. Like that's a problem.
Sure.
So if I'm there and I hire you, I know you're coming at me with a price tag. Like, well, listen, we're going to need $400,000 to fix all this. Like, was that a hard sell? Did you have to go to them with a with a ticket item of like, we need to buy stuff.
So certainly, yeah. I mean, there was a lot that needed to be addressed. And so it was trying to prioritize in this dumpster fire, what's like the biggest fire that I can take care of first. That's going to have the most impact on everyday working lives here. What do we have to get done? And it really came down
with the budget they have, right?
With the budget that they have.
I take it.
Yeah. Because I feel like nobody wants to spend money on infrastructure. I mean, I got them into that predicament kind of, right? Like, well, it just works. It's fine.
And that's why it was neglected for so long. Right. And then they just kind of like dealt with stuff that it's like their application server had to be rebooted every day. Like otherwise it would lock up and then they would have to reboot it anyway. So they started preemptively rebooting it like a scheduled reboot. And then everybody was just okay with that. Just like, that's not okay. we don't need to do that.
Oh.
So I'm trying to guess what like you said, what can I come in here? So like design conversation, right? Like look at this awful design. I don't know what your budget was. I'm guessing that so what would you have to do? Like, I mean, you don't need a core distribution and access, I guess, right? Like I'm guessing you're replacing those unmanaged switches with like managed switches.
Yeah, this is enterprise design, right?
Well, we did have to design a data center of sorts, right? Like it was like one or two server racks and a telecom rack. Yeah. So and that was the first thing that we had to do was identify a better location, right? Like the server room that ultimately like was there when I walked in the building first, it was right next to a cube farm, and the room that it was in was not like soundproof in any way, shape, or form. And so it was loud. There was a wall-mounted AC unit that kept it decently cool in there. But the servers were old. They were super loud. They were like closest to the door in that room. And so all of that noise you could very easily hear out, in the bullpen area or whatever, where everybody sat and tried to work. And it's like, okay, there's a better room in this facility that's more centralized, and it's surrounded in concrete because it's part of the building that houses the elevator shaft. So let's throw it in there, and it's going to be a lot quieter and more centralized. So now we're going to pull some fiber back to this room, and that's what we're going to do for the networking. Now, all of the access layer stuff was already pulled like out to the wall, right? And it would just be way too expensive and cost prohibitive to like rerun every single drop in the building to a new place. So we had to go with the access layer switch locations that we already had. Patch panels were already there. So we couldn't rerun that. But what we did do is run fiber from those locations back to the new server room, because that's where we would put the new core switches.
So you move the servers.
Yep.
You put in core switches,
proper cooling, redundant power.
And you ran fiber from that core to each access switch out. Is that what you did?
Yep.
Okay. Is it a pair of pair of core switches or just one?
It was a pair of switches. Yep.
You really redid like everything.
Yeah.
Huh. Okay.
So
how long did that take?
I guess you could do it in one night, I guess, right? Like the cutover, I'm thinking. Like how long were they down?
So the server room move, what we did was we bought new servers and we migrated applications into the new environment. So we went with virtualization. So we got 3 new servers for compute. We got a data store, and we ended up doing a P2V, which is a physical to virtual, on some of the applications, not all of them. And then we built net new virtual machines and just migrated the applications over to those. We did a backup of the database one day, did the restore, and then...
This doesn't sound cheap.
I mean, on the scale that we were operating at, it wasn't... It was probably... It was pretty expensive for the business at the time.
But good for them that they had... I guess, I don't know if the foresight's the right word, but...
Well, it was just education, right? Like, every time they wanted a new application, they had to buy a new server because they didn't have anybody that did virtualization. And so I showed them the power of virtualization. Huh. We're going to buy these 3 servers, and it'll be the last 3 servers you'll need at least for a few years. Right?
Yeah, right.
Yeah, that's wild.
And I guess that's tough, right? Trying to convince the business to spend money on infrastructure. I mean, that's got to be an art to that, I guess. Like you have to make that case for it, right?
Sure.
Like, oh, this guy just wants to come in here and buy all this stuff. Well, hold on. These are the benefits you get, right? These are the pain points that we're going to alleviate from this.
And that's what a lot of the design discussion was look, this is a pain point for us. The business wants to scale and wants to move. We want to try new applications. We want to do all these things. But every time we do that, we have to buy a new server. Like the ERP system was incredibly old. It needed an upgrade. We needed a new server for that.
What's ERP?
Enterprise Relationship Program. I forget exactly what it stands for.
Is that the sales tracking stuff?
Yeah, pretty much. It ultimately ends up as like your financials. Yes, sales uses it and manufacturing uses it, but when it comes right down to it, that's your financial reporting.
Right. Okay.
Like you're punching how many hours it took for somebody to build a pump. You're tracking all the parts and raw materials that people are moving through the shop. You're collecting all the sales from the salespeople like into that system, and ultimately it spits out your ledger. Hey A1 fans, AJ here for NetAlly. Never heard of NetAlly? Sure you have. They came from the same group of engineers that brought us network tools from Fluke Networks, NetScout, and now they're NetAlly. They know networking. I'm a network engineer for a partner, and when I go to customers and see they use NetAlly, I know it's going to be so much easier to troubleshoot issues we might run into. The name may have changed to NetAlly, but the way they build tools hasn't changed a bit. They ask, what would a network engineer want to help make their job faster and easier, and then they go build it, just like this Etherscope NXG. NetAlly is here to help. NetAlly, simplicity, visibility, collaboration. Visit netally.com today. Now back to the show.
So Lex had asked earlier, how long did it take? Sorry, I stepped on you, Lex.
It was a very iterative process. So, the first part was probably done within the first year. So we got all of the old systems moved over into virtualization. And then the next request came down was the CEO of the company wanted everybody to have the same email address. And because the HQ,
domain, you mean?
The HQ of the company was in the UK, and they were using one email domain, and we were over here in the US, and we were using a different email domain.
Okay.
And it was kind of a convoluted thing. And so I had to collaborate with the IT directors in other countries to get us all in the same email and domain.
Wow.
Like Microsoft.
How long have you had this place? It sounded like it did a lot of good stuff.
I was there for 6 years.
Okay. So it took you 6 years to fix them up before you decided to move on.
Yeah, like towards the end, like the servers and stuff that I had, designed and installed, shortly after getting there, we were literally retiring those the day that I walked out.
Oh, wow.
Yeah.
Wow. So I was going to ask, what next after you finished all of that? Was your job super boring after that? I mean,
right.
Did you have anything to do?
There was always some improvement to be done. It was, like I said, it was very iterative, right? Like we started on 3 physical servers and then a SAN for storage. But by the time that I was leaving, we were moving to hyper-converged.
So they continually were investing in keeping things up to date
because they saw the power in that, right? Because when I started there,
props to them.
When I started there, they the most they had made was 18 million in a single year, which was great for them, they thought. But by the time I left, they were making 60 million a year.
Okay, so they could afford it, and they were all right with it. That's good. That's great.
And I think that
you don't hear those stories a lot.
After the first iteration, after getting onto the new servers and realizing, I don't have to, reboot my application server every day. And, hey, it's responding a lot faster. And, we got all new high-end desktops for the guys that were doing the AutoCAD, the drafting and stuff like that. And they could actually work. They didn't have to sit there and wait a super long time to open up a drawing. It just opened and they could start working.
Those employees must have loved you.
Yeah.
I mean, you improved the quality of their employment there so much. Wow.
So there is a data center design discussion in here. When we're, even though that was a small room, right, we still had to do the same data center design that we would for any scale of a data center. We had to have cooling. We knew that we're going to have servers and networking devices in there. They need to be kept cool. When your cooling dies, you're going to have, depending on the room, you're going to have maybe a matter of time before that stuff starts to overheat and causes, critical damage to those devices. So cooling is of the utmost importance. In a proper data center, one of you guys mentioned it earlier, you're going to have a hot aisle and a cold aisle. Cold aisle is where cold air is either dumped in from above or comes up from below. Some data centers are on raised floors, and you can take these suction cup things and pop the tiles up out of the floor, and that's where your cold air comes out of. You can place vented tiles in front of server rack doors, and the cold air will come up from the bottom, and the servers and devices in the racks will pull the cold air into the front and exhaust the hot air out the back. And then the hot aisle is where the hot air is exhausted into. The hot air gets taken away by the HVAC system and either exhausted out of the building or chilled and dumped back into the cold aisle.
Interesting. I can't tell you, I've had to work on a number of stupid issues in the past because, the stuff was in a data center that had something wrong with the hot and cold aisles. I don't know exactly how they were set up. But things were too hot and optics were getting messed up and failing way too fast. We had I remember just an order of, I wish I could remember what they're called. They're a single piece where you have the, the connectors at the end, the SFPs at the end, and the, cable.
A direct piece. Attached. Usually a DAC.
So we had to, I think I did 80 of them in a month just in the same data center because it was so hot and they couldn't figure out how to fix it without taking things down and moving things around. So there's real implications, real bad stuff happens when that stuff is not designed properly.
Absolutely.
Oof.
Yeah. So even in that cooling discussion, when we're looking at that room, it was a small room, and we knew we could get an AC unit mounted on the wall. That wasn't an issue. It was going to dump cold air right directly, within feet of the rack, right? There was just enough room to open up the door on the server rack, and then we would dump cold air into the front of it. I discussed with them that we needed to have something to pull the hot air out of the room. And they're just oh, it'll be fine. Don't worry about it. I'm no, it's not going to be fine. I am going to worry about it. So they didn't do anything to pull the hot air out of the room. And sure enough, it got ridiculously hot in that room.
So what do you use to pull when you're a smaller, organization like that, and you're not in a big industrial room?
Right.
What do you use for that?
So the top of the AC unit, the wall mounted AC unit, had a vented area that would pull air into it. But the problem is that hot air wasn't making its way back up to the AC unit. So to provide a temporary fix until we could figure out a better long-term fix,
didn't you?
Yeah.
We had a fan right behind the server rack that blew the hot air up, and it forced it back towards the air conditioning unit.
But that helped, right?
It helped. It helped a lot.
But it was temporary, you said?
Yeah, it was temporary. Eventually, they addressed the HVAC system to be able to pull the hot air out.
Yeah, I mean, I guess you got to put some, you got to run some vents and fans and suck it out somehow, right?
Yep.
And you have returns in HVAC that sucks air out, so I guess they just had to pay for that. And
right. And there was no proper divider, right? There wasn't a separation of the hot and cold air. It was just one single room. So eventually that hot air would just get hotter and hotter and hotter.
And the cold air just wouldn't even have a chance.
The cold air didn't have a chance at all.
That's wild.
So something just jumped into my head. Oh, go ahead, Lex.
I said physics. That's all.
Oh, physics. So I don't know if it's not part of a data center design discussion. You can tell me it's not, but I never understand why people pick certain routing protocols over other certain routing protocols, right? You can choose. So when you're designing a data center, we're talking about physical infrastructure now, right? But there's logical stuff. We talked a little bit about logical earlier, quality service, and and all that stuff. Maybe spanning tree around. So, I mean, how do you choose a routing protocol? Because again, architects design stuff and it's a Cisco shop. They're running EIGRP, or they want to be multi-vendor, so it's OSPF. I mean, is it that simple? Like
it is. It really comes down to what vendors are you using and what is the familiarity of the staff that needs to run it. If all of your engineers that are maintaining the equipment are classically Cisco trained and have used Cisco for years, not to say that it's impossible, but suddenly pivoting and going to Juniper or any other vendor that does not have CLI like Cisco, there's going to be some turmoil there, friction. Right? Like some friction, right? Like operationally speaking, you're going to need to make some investments to get them trained, which is going to add to the cost, which may or not be, more or less than just sticking with the vendor. This doesn't even have to be a Cisco discussion, right? Like it comes down to what's the comfort level of the engineers that are supporting it right now today. And
the other logical stuff, go ahead.
And that could it doesn't even have to be physical gear. It could be the technologies that you're running on there. So are they more comfortable with OSPF? Are they more comfortable with IS to IS? Are they more comfortable with the IGRP?
Right. So either vendor, lock-in, or your staff.
You just don't ask what people are comfortable with and you do whatever you want. And then they have to learn it real fast.
So is it, I'd lean to the cynical side because I think it's more realistic. Like, do you think the routing, I feel like places buy into vendors, right? So if you've bought into a particular vendor solution, so like I worked at a Cisco shop and they ran EIGRP everywhere and then BGP at the edge and they redistribute, one into the other.
Right.
But then I worked at a multi-vendor shop and it was OSPF. Mm-hmm. Right. So, I feel like, I'm wondering how much decisions like logically are based on like, our staff is more comfortable with this and this is a better protocol, or this is the vendor we locked into and this is, like we're either multi-vendor or one shop and we have to use this one particular protocol. Like, do you think vendor decisions, the iron you buy and the ecosystems that come with them, do you think that drives design decisions at all?
Absolutely. I think there's a lot of different like philosophies, right? Like, when I was managing the environment, I was of the opinion I wanted one throat to choke, right? Like I didn't want to have to call one vendor when my servers went down. I didn't want to have to call a different vendor when my data store went down. I didn't want to have to call a different vendor when my network went down. I didn't want to have to call a different vendor when my mailboxes went down or whatever. I wanted one vendor, one support line. It just made it quicker. I didn't have to stop and think about like, oh, that system went down. Like which 800 number do I have to call now?
Be nice.
Right.
Right. And so we went with a Cisco hyperconverged platform, HyperFlex. We had a Cisco network. It's because we bought HyperFlex, even though it was running VMware, we still got our VMware support through Cisco. So Cisco was our single throat to choke.
So you're just dealing with them and then they're reselling you all the things.
Yep.
Is HyperFlex like their server?
HyperFlex is their hyperconverged offering. So
the HCI.
Yeah. So HCI is really cool because you used to buy, pizza box servers, 1U, 2U servers that had some storage on board, but, that was probably just for the applications, the operating system. And then, if you needed a lot of data, you would get a data store, a SAN or something like that, right?
Yeah.
Well, HCI is all of that crammed into your pizza box servers. So you would already have a distributed data across however many, devices you had in your or HCI boxes you had in your cluster. And you could scale with HCI just by adding another unit. What's really cool about HyperFlex is that you could have compute heavy nodes and you can have data heavy nodes and you can mix and match. Most other HCI hyperconverged vendors don't have really one or the other. If you needed more data, then you couldn't like mix and match like you could HyperFlex. That might be different today. I don't study HCI a whole lot anymore. It was years ago when I first was evaluating HCI vendors.
So is their UCS platform considered HCI or is that a different thing?
HyperFlex is built on UCS.
Yeah. Okay.
So those are all UCS nodes.
Managing some UCS. Yeah. So the UCS, because I remember they seem to have way more stuff in the one box, right? Instead of like you said, external SAN somewhere, it was all built in into that one box.
And you usually with hyperconverged, you're seeing a whole lot more processors, a whole lot more memory, a whole lot more storage, all built onto the same box.
So there's an advantage to one throat to choke, right? Because it's simpler and you have one place. You got one person you can say, hey, fix my stuff. Is there any downside to one throat to choke?
Absolutely. Software bugs, baby.
Right. Right.
If you get a single software bug that applies to a lot of devices in your network, then that one thing, that one bug could cripple your entire network.
I've run into that.
And that's
we have
a lot
to
of
upgrade
reason.
Everything tomorrow.
That's I think one of the bigger drivers for people to, spread out the love when it comes to purchasing and stuff like that. And then there's also like a piece of it, like keeping the vendors honest, right? Like if you go with the one throat to choke model, if it's possible that the vendor could, charge you more because they know you're going to buy that vendor.
Right.
So by keeping the vendors honest, like, oh, well, I'm going to buy vendor A over here, but vendor B over here. And people feel like they're constantly getting a more competitive price.
I've been in I'm sorry.
No, go ahead. Sorry.
I've been in multi-vendor environments before where we would find a bug that was kind of far-reaching on a lot of devices we were using with one vendor. So we would, and by we, I mean like the organization, not like the network team or something necessarily, but we'd basically use that to threaten them like, oh, well, we're going to go with this other vendor if you don't fix this bug like pretty quickly and give us like a way to upgrade and fix it or a solution fast, which was an interesting way to handle it. But I guess you got options when you have a multi-vendor environment versus just one, right?
Right.
Just like you said.
Right.
I've seen vendors pitted against each other too.
Oh, sure.
Kind of like you're saying, AJ, like if you're with one, that's it. But you can go to shop A and be like, hey, shop B over here. Even if you're intending to stay with your incumbent provider, like, well, I'm shopping around and they did this POC and there's this price and it looks pretty good. And I've heard people kind of do that to try to get a better price. Have you seen, or do you think that we're heading in a direction where you think vendor lock-in is slowly going away? And I say that like, so we just talked to Itential, recently, and, they have this automated solution that like, they don't care what stickers on your iron. And Juniper, like where I'm at, has like, I'm seeing more and more of these solutions of like, vendor agnostic, like you can design, deploy, and maintain your infrastructure no matter whose stickers on the box in this, don't say it's single pane of glass, right? But like, so, I wonder if we're getting software defined networking, I guess, right? Like whatever the thing, du jour is, but it seems to be that the brains are coming out of the iron, going somewhere else, controller based, whatever. And I just wonder if being locked into one vendor will be a thing of the past someday, because it's not, I don't know if it's going to matter as much if we're taking the control out of the control plane and putting it in some type of controller or brains or management system, automation platform, right? Like,
right.
Is it considered like more old fashioned to stay with one vendor these days? Or does everybody sort of have a different opinion?
I think it's differing opinions all over the place. Okay. I mean, there's someone could perceive value in staying with a single vendor because then you get the vendor's total story, right? Like if you have their firewalls, if you have their data center switches, if you have all of their stuff from A to B or A to Z, then you get the total story, the total picture, right? Like if you have just Meraki switches, you can see a lot about the clients that are on the network. But if you have Meraki switches, you have Meraki wireless, and you have Meraki firewalls, you're going to learn a whole lot more about your network. You're going to have a whole lot more visibility. And
that's intentional by vendors, right?
That's intentional, right? Exactly. So that's why with these automation platforms, like you're getting a whole lot of analytics and knowledge about your network because it's that, vendor end to end.
Whereas with solutions that are vendor agnostic, they kind of help you bypass that disadvantage maybe of using multiple vendor stuff.
I think a lot of the vendor agnostic stuff out there now, like, yes, you can have a central management device or operation or application that can manage all of those devices, but I still think I don't think you're getting as much telemetry and application data and knowing what's on your network if you're multi-vendor. I could be completely wrong. There's a lot of cool solutions out there that I, don't see.
I've heard that said, right? I've definitely heard that said. And I think there is something about like, well, I got this one vendor, I got all their stuff. And it almost reminds me of Apple. Not that has anything to do with like data center design, but it's, it's a closed ecosystem. It's tight. The software, the hardware, they're tied to each other. And it gives you certain advantages and features that you might not get in, in a different distributed, different software running on their hardware. Like it's why the experience with their hardware, I think, is so good because it's just so tightly together. So like for a networking equipment, they're probably doing a similar thing. Like you're saying, you have more insight, you can see more things, you buy into this whole thing. But damn, if you hit that bug or if the relationship goes sour, or I'm kind of excited about like a lot of the automation platforms. And, I hear that we're going to be able to do this stuff without so much of that vendor lock in. And I guess it seems like we have some ground to cover to get all that insight, like you're saying, in the telemetry application, like, because, vendor A might not want vendor B to see this special under the hood, hidden thing, right? Like, oh, if you stay with us, you can see this stuff, and they can't see that, which stinks, right? Because we're running open protocols. Like if we can run OSPF everywhere, it kind of stinks that the vendor is like, yeah, but there's special things that automation platform can't see that ours can, so I hope we get to a point where it's just one thing. Like, I don't know how important the stickers on the boxes are, is all I'm saying, for operators. Like, I've never cared what I'm running. When I worked at Comcast, they had everybody's box. So like, why would I be allegiant to any one of them? Like, okay, we're running everything. Great. Whatever. I feel like the bigger places are. So we need solutions that are vendor agnostic that can help operators like that manage that infrastructure easier, instead of having to log box to box to box when something goes wrong. Like, which one's messed up? I don't know. Let me check the logs.
And
it's so nice to just have...
Those solutions are targeted towards larger enterprises, right? Because you have larger teams of people that can better manage those types of things, right? Those different vendors. Whereas...
Are there a lot of large enterprises with multi-vendor environments, or are there more? I mean, is that more common than having like a huge enterprise with the same vendor? Did that question make sense? Do we know, I guess? Like, is there any way to know? I don't really have I still don't really know the trends in networking, to be honest.
AJ's probably seen more environments than us. So, like I've seen 2 environments, right? You've worked in so many.
I will caveat that by saying I've seen a lot of environments, but the partners that I work for typically feed one beast.
Yeah.
Right.
Really?
So most, like, not to say that they don't sell others, but the work that I do, it's typically 90% of the time it's one vendor.
Why do you think that is? Maybe this is a different show. Maybe like vendor lock in, and I mean, I don't know, right?
It could be the place that I work for. It could be, I think it could be a number of different factors. I think in the end, I haven't seen enough to give a definitive response. I think part of my view is skewed either because of where I work or just whatever, any number of reasons.
So you're saying you have more Cisco certifications than any other vendor, is what you're saying?
No, I'm saying that most of my projects that I'm installing Cisco gear.
Right.
But that's not, that's not to say that there's other engineers that work where I work that install other devices. We have plenty of other engineers that install plenty of Arista. I don't see that.
Right.
So I don't know how much of them are doing that, but I know that they're out there. We have teams of people that do Aruba and Arista and, plenty of other manufacturers. I happen to be Cisco certified. I have more experience with Cisco than other vendors. Hey, A1 fans, AJ here to remind you about NordVPN.com. NordVPN will help secure you wherever you go. I use NordVPN on all of my personal devices. Whenever I'm out and about, I just go into the NordVPN app, hit Quick Connect, and away I go. nice and secure. Don't have to worry about prying eyes, anybody looking at my connection. If I choose to go work from a coffee shop locally, or even while I'm traveling, if I bring my personal devices, I will use NordVPN to help keep things safe and secure. I'm using NordVPN right now, and there's no degradation in my signal. Everything looks good when you guys watch us on the live streams. So I can't say enough good things about NordVPN. They have some great additional services included with their VPN product. They'll scour the dark web for your credentials and see if they've been involved in any sort of hacks or anything. And then if they have, they'll let you know, and you can go change your passwords and do whatever you need to do to help keep yourself safe and secure. They also have a mode that will block any websites or ads known to possess malware, and they just have general ad blocking anyway, because who wants ads? As I record an ad. Anyway, if you want NordVPN, and you do, go to nordvpn.com/TAONE for the art of network engineering, and you can get a really great deal, 73% off 2 years plus 4 months free. So again, that's 73% off 2 years plus 4 months free of NordVPN. If you forget that URL, just go to nordvpn.com. At checkout, you can use the promo code TAONE for the art of network engineering. And we appreciate your support, as well as NordVPN support of the Art of Network Engineering podcast. Now back to the show. Chris Denny is asking, are there any physical concessions you've had to make because of one vendor or another? Physical concessions, no, not that I can think of. I will tell you, in my experience, one of the reasons when we were looking at hyper-converged infrastructure, the servers, one of the reasons why we went with Cisco's platform over another vendor was because another vendor wanted you to have, almost required you to have 4 nodes in your cluster, whereas we could get away with 3 nodes in our cluster. And they kept saying, oh, well, it's so you can put 1 node in maintenance and then you still have 3 other nodes, and then so you could sustain a failure. But the problem is I was already licensed for 3 nodes. I already had enough VMware licensing. I already had enough Microsoft licensing for 3 nodes. Even though the initial cost comparison, even though I was buying 4 nodes, it was still a little bit cheaper than the 3 nodes that Cisco had in my quote, but the Cisco nodes were also beefier. So it wasn't an apples to apples comparison. But then if I went and added on the additional VMware and Microsoft licensing that I needed, that was going to put me over than the Cisco quote.
So can you quickly define nodes? I mean, are you talking about a rack with servers and a top rack switch?
Yep.
Or?
And each server is a node. So when I'm talking about like my hyper-converged cluster, it's a bunch of servers that are sharing the same resources.
Okay.
Right.
So whatever you were trying to build HCI and the vendor said you need 4 for the design. You were like, I don't.
Minimum 4 nodes, like end of discussion. Sorry.
So was that their design requirement, or is that a way to sell more gear and licenses, or both?
Why?
I think there was something in their secret sauce that they needed a minimum of 4 nodes.
Yeah.
Interesting.
However the technology worked, maybe, or the things were designed.
Yep.
You needed an even number, maybe, or whatever, right? Who knows?
Huh. So no power or temperature limitations you've run into?
Power has certainly been a problem. The server room that we built was power limited because of issues in the building, and we definitely had limitations with UPS. I have a hell of a UPS story for you.
Tell it.
Do tell.
So we had a UPS system in the server rack, and when we initially got it, we wanted to put it on the network so we could network manage it. But the switches that we had completely full, couldn't add another network drop in there. We upgraded our core switches and the switches throughout the building. Yay, we have more ports. Now let's connect our UPS system so we can manage it remotely. So I was the IT manager / infrastructure architect for this company. I'd hired a sysadmin. The sysadmin goes up to the server room to console in to this UPS. Completely unbeknownst to us, apparently there are 2 different styles of console cables for this UPS vendor. And when you use the wrong console cable, it shuts down the UPS. Like
what? Why?
Completely shut it down. And because the PDUs, the power distribution units, were plugged into the UPS, when the UPS shut down, like hard down, that shut down our entire server rack.
Plugging in the wrong console cable took down a whole server rack.
Is that like a weird security thing?
That's
like,
a bad design.
No. This is someone's trying to hack into the mainframe. We can't let them use the wrong cable.
And the differences between the 2 console cables were very, very minute. Like just looking at it, you would never know.
Like, was it a pinout difference? Like
I can't even remember like what the difference was. It was like a generational thing, and
that's goofy.
Yeah,
it's one thing to not be able to connect to the console port with the wrong cable,
right?
To take the thing to its knees.
Oh man.
And is that by design? Like that's supposed to do that?
I don't think it was intentional. It just, that's the way it ended up. So they just, they put out a bulletin about
it. So you guys probably discovered it. And they're like, oh God.
So
they wrote the bug for you.
I was at my desk and like the internet goes down and like we couldn't get to any, like even internal services. So I'm like, well, that's weird. So I go up to the server room and my sysadmin is like on the floor, like with this terrified look on his face. I'm like, what happened? He's like, I don't know. I just plugged in the console cable and everything shut down.
Poor dude.
What did you do?
Like everything was off. Like I'd never heard that room so quiet. I'm like, oh, this isn't good.
He's probably going to tell that story for the rest of his life. The day he almost had a heart attack. Thought he took it all down just plugging something in. That's the first. Dang.
So AJ, what would you tell people that are like just starting out and want to get in? Like, I didn't learn design, right? Other than the minimal 3-tier stuff that was in the old school CCNA. And, Lex and I are both, hey, AJ, teach us about design. We never, I've always relied on architects, right? And Lex is like young, like earlier in her career. So
I don't know anything.
But I mean, I feel like I've done myself a disservice that I haven't learned more about design because, I mean, if you're a network person, maybe you want to be an architect someday. And I know it depends on the role in the company, but my experience has been the architects do the design. And if you don't know design, you never be an architect. So like I would have probably never become an architect in my career in operations until I learned enough design to be able to design a network. I mean, it sounds silly to say, but like I said, I wanted to be an architect on early shows and every architect we had, I'm like, ooh, tell me more. But I never spent any time learning design.
Right.
So, I mean, you need to know design.
Right.
Period.
It's just...
Don't do what Andy did, is what I'm saying.
And I think that's probably more common, right? Like you work at a large you worked at a large organization that had architects. And like I said, anywhere that I have ever worked, never had architects. So it was up to us to understand the technology, understand best practices, design for a given technology. Most vendors will do like a verified design, right? Most vendors have a verified design for whatever platform they're selling, whether it's like servers or storage or networking. So those are great documents to go through and understand, what are the tested, approved, validated. And when they say validated, it means they took this equipment, they set it up this way and it works. And these are the speeds and feeds they got out of it. So
what did you call it? I thought that was like a design guide. Or am I using the wrong term?
Usually it's verified designs.
Verified designs. Okay.
Vendor verified designs, Cisco verified designs, Dell verified designs.
So your boss says, hey, we want to deploy this thing. Go check it out. You can go get whatever that document's called.
Verified designs, validated designs.
Verified this is what you need. This is the gear. This is the,
And they'll give you like some various scenarios like, oh, well, we were deploying this to support 1,000 different locations or whatever. And here's how we did it.
Because what's interesting? I never needed to know design because I never built networks.
Well, no,
right?
Yeah, like,
you built the networks with someone else's design. It's just like building a building, right? Like there's an architect that builds the building, and then there's engineers that, physically build the building.
Right. Yeah.
So is the moral of the story kind of like, if you really have your sights set on being an architect one day, you should try to find a position where you're kind of going to be forced into that role in the first place, but maybe not with such high stakes. I don't know. Like that's how I would think of it. If I wanted to be an architect, I wouldn't want to be just like thrown to the wolves, but you also do want to learn, right? And that's how you said you learned, like by having to do it, having to know that technology and designing it and going with it.
Was it out of necessity, AJ, or were you interested in design? Because I guess I've never been interested in it because I go after things I'm interested in, and other people were doing it for me. Like, was it necessity for you because you had to, or were you like, ooh, I want to know how things are built correctly. Let me go learn it. Or maybe both.
It's been a little bit of both, right? Like I've worked places where it was bad, and it was bad because there was no design. Nobody sat here and thought like, here's how we're going to do it so it can scale, so we can grow bigger. Or, it was just, there's a need, let's fulfill the need. They didn't really think about how they were fulfilling the need. They just checked a box, right? And it was
short-sighted, right?
Very short-sighted, very short-sighted. And so through dealing with the bad stuff, I just grew an appreciation for doing it the right way.
Right. Because there's like in the design, there's like modularity built in, right? Like if you follow this design and you grow, you can add modules onto this existing design and it'll work, not plug in another unmanaged Netgear switch in another closet.
Modularity.
Right?
So like your troubleshooting domains are like a certain area, like stuff can only break within certain confines, right? Like then you have redundancy.
So troubleshooting.
You have redundancy, like something can break, a certain number of things can break and you'll still be operational. And that's all important pieces to keeping any business going, right? Like you need to be able to sustain certain failures.
It's not like redundancy, resiliency, something else, availability, maybe.
Yep.
Like
I hadn't considered that. It'll help you isolate the fault domain if it's designed correctly. If it's just the Wild West, God knows anything could be broken anywhere, right?
Right.
It's probably harder to fix. Yeah. Huh.
Do you feel like you made any mistakes when you were trying to implement, design that worked better? Like, do you feel like you made any like silly mistakes that you learned from, or were you pretty much there? Okay.
Without a doubt.
Like, did you try silly stuff at first that you didn't realize was silly till you did it? I feel like that's what I would do. I'd just fuck it all up and have to start over a couple times.
So
sorry, guys.
I don't know. It was a lack of networking knowledge. And it was a lack, perhaps, of networking knowledge on the partner side as well. So when we got new switches for that manufacturing company I was working for, I had to settle for HP because they didn't want to shell out for Cisco. I was more experienced with Cisco. They didn't want to shell out for it, so we went with HP instead. The two core switches were not stackable, so they had to operate independently. And I took that at face value. We didn't build any redundancy in it, but my trusted partner, didn't push me in that direction either. Now knowing what I know today, we could have had a first hop redundancy protocol running on both of those switches and protected the gateway. I didn't. Right. I was running all my layer 3. You just
had to run a cable between them and run HSRP, right?
I had I had one switch that was running all of my layer 3. That was my spanning tree route, and all of the servers connected to that switch. And then I had another switch that was basically the distribution to the building. All of the switches throughout the building uplinked to that switch. And like thinking about that and knowing what I know today, I'm almost embarrassed to say that that's how I deployed that so many years ago. But I didn't have the experience then that I do now. Right? Like that could have been designed so much differently and better than it was.
No, that's not embarrassing. That's what I was looking for. Honestly, it was like something that
I'm embarrassed for you, AJ. No, I'm just kidding.
I feel like I would do that if I were just kind of feeling around in the dark, trying to figure things out. So
absolutely,
I can relate.
Well, I do know that it even though we didn't do like first hop redundancy protocol, I do know that what I wanted was additional bandwidth to be able to go out, like the redundant links and the higher bandwidth going out to all the switches. So, having port channels out to all the switches, I got my redundant links. I satisfied that requirement. And I got the higher bandwidth. If I had to use spanning tree across both of those switches, one of those links would have been shut down by spanning tree, and I only would have gotten a gig out of it. So to a degree,
spanning tree.
I had to do what I had to do to satisfy the requirement, but I did it also because that's what I knew how to do, right? Like I could have done it a different way, but it wouldn't have satisfied the requirements.
I know we're going to have to wrap soon. We're getting way toward the end here, but you said spanning tree route, and I just want to tell one more quick story because it gave me, I just had PTSD when you said it. Story. So like logical design, right? Spanning tree, we had an NMZ zone, which is say 2 aggregation switches, 2 distribution, and then they went to a third pair. Maybe it was ag and then distribution, and then there were firewalls down. But anyway, it was for non-managed zone for clients. They could come in, we give them a cable, and they could get the services. So it was all end of life, and we had to replace it. So we put all the good new stuff in there. I was responsible for that. They shipped, the gear went out, whatever. But I forgot to set a spanning tree route because I have so little experience in layer 2. I'm like, I didn't even think of it. Thought never even occurred to me. So anyway, the route shouldn't be on an access switch, right?
Oh, no.
No.
Right. So because, and again, now we're like CCNA level questions, right? So if you don't set a route, it's all that 32, whatever priority thing. So then it goes to like
the MAC address.
Yeah. So what does it go to? The MAC address?
Burned into the brain.
So the long and short of this whole ridiculous story is one of my access switches was the route because I didn't design spanning tree at all. I didn't even think of spanning tree. And then I don't know if it was like root guard was then on the ag switches, but because that was the route, these ports shut down and or maybe it was root guard, whatever it was, I forget because I'm so layer 2 challenged. But I had this whole huge mess of what is happening? Ports are shutting down. I can't get them up. I'm getting weird log messages. Why can't I get these ports up? Just because I didn't design spanning tree not only properly, but at all. I figured, you just put in switches and it'll work. So, like you said, you just didn't know any better. I mean, I should have known better, but it was my first time dealing with the spanning tree design. And I never even, after that, now I've never made that mistake again. I better decide what the route is and do that command to make it the route. You don't know what you don't know, right? And I had learned about spanning tree and CCNA, but I had never built and designed a spanning tree, design that. So anyway, I seem to learn best when I do things wrong and break them. And then I'm like, oh, right. That I won't do that again.
Hashtag lab every day.
Lab every day. Lab and prod. It's still labbing.
Yeah, there you go.
Yeah, it's the same thing.
So anyway, I like our design discussion.
I'll piggyback off of your spanning tree story. So, first, Chris Denny asked, do you think your job at Avar has helped push you along this path? Absolutely. So I'm a senior network engineer. I do post-sales deployment. I get handed designs, pre-sales designs from architects. They're design architects. They work with our customers, solution architects. So they'll come up with a solution, design it at a very high level, and then I get to take that design, validate it against the customer's environment, and then do a lower level design and really pick out the details. So I love that part of my job. That's one of my favorite things to do.
Sounds pretty fun.
Yeah. So to piggyback off of your spanning tree story, I visited a customer last year. They have a very large campus, and I get in and start looking at their switches. I was not allowed to remote in because of the security of the environment. And so I get on campus and I start looking at all their switches, and every single switch had the default spanning tree priority. And somehow the core switch was elected root, but I feared that installing the switches I was there to install would have changed that. So I told them that before we do anything, we are going to set some spanning tree priority in this bitch.
Exactly how you say it too.
Because and then on the reverse end, this was a very large sprawling campus. was for like a park, right? You go visit a park, huge campus. They have facilities where people live. They have facilities where people work and store stuff and do various things. So it was a perfect use case for these small work group switches, these small 8-port PoE, because they had voice over IP. And so even those had the default spanning tree priority. And even though all these protocols have elections and things like that, if I don't want something to ever be the spanning tree route, I'm not going to leave it the default value. I'm going to set it as high as I possibly can to prevent it from ever being elected the root switch.
Andy went in and installed that, right? And Andy went in and was like, switches, just do switching. It'll be fine.
Right. Yeah, I took all of those. I touched every single one of those 8-port switches, and I cranked the spanning tree priority as high as it would let me go. It's 61,000, whatever. So that way, that would.
So by some miracle, their core switches had I forget if it's the highest or the lowest MAC, but whatever the hell the thing is. So by some miracle, their core switches had the lowest MAC because everything was at default.
Right.
Wow.
Yep.
Wild.
Wonder if that person's still out there doing that dumb stuff.
Yeah, it was crazy to me. I was just like, oh my gosh, this is like a house of cards, right? Like it could blow over at any second. And they would have no idea
how many
why.
Devices were participating in STP that could have
it was pretty big.
Could have had like a root switch all the way like a mile away down the green in a tiny little closet somewhere.
Exactly.
Last question. What's the diameter of spanning tree?
I forget what you can set the maximum diameter to, but the diameter is from your core out to your distribution layer, out to your access layer. And you can continue to daisy chain or hang switches off of switches. It's not desirable or preferred or recommended, right? But the diameter it should be an equal number of hops from edge to core.
But is there an upper limit where you got to stop hanging switches off of switches? Is that what the diameter is? Is like things will stop working once you've daisy chained to 27th
after
switch,
like a certain distance, you're going to just introduce latency and all sorts of nastiness.
Yeah. And doesn't spanning tree stop working? I swore something weird happened when you...
I just Googled it. I'm not going to pretend I'm smart, but there's a max. It's 17 switches is the max.
17. Okay.
Yeah.
Good job, Lex.
Yay, I Googled something. A very important skill for a network engineer. I have mastered it.
Good work.
Awesome. Well, this has been a fun discussion. I didn't think it was going to go this way, but I certainly had a lot of fun rehashing some fun memories.
Thank you for teaching us, AJ. This was really, really helpful.
I hope everybody got something out of that. My rambling.
We only lost one Patreon, great. So it was pretty good. We've been going a while and only one drop.
Well, we did get some great questions from our Patreon family this evening. If you're interested in joining our Patreon program, you can go to patreon.com/artofneteng. And we have a couple of different tiers of Patreon membership, and you can join the live streams. Some of our Patreons get early releases of our podcast episodes. That's a new feature. That was Andy's idea. I can see he's raising his hand.
No, I'm raising my hand because, how dare you? I'm raising my hand because I want to make sure that we mention our new merch for, don't we have some new merch soon?
Thank you, Andy.
Yes.
Yeah. I am super excited.
You tell us about it, Lex.
We now have women's sizes, women's cut tees in the merch store. And I have my eye on a particular crop hoodie I'm very excited about. So it can be stylish. It's for ladies, men, whoever. Nice. Now we have all the sizes.
I will say our merch store. So we do our merch store through print on demand. So we don't bulk order merch, store it at my house, and then I ship it to you. We use a platform called Teespring. I think they're now called Spring. And they have a catalog of merch that we can pick what we want to put our logo on, and then you go to our store, buy those items, and then they will print it. Every so many days, they'll run a bunch of orders from our store, print them, and ship them for us. They handle all the overhead. We don't pay for this service. We just get a cut from whatever you purchase. We set the prices. The prices are set I think at a fair price, so that way they're not too expensive. There's like the recommended price, and then there's like the A1 price, right? Like we knock it down for you. So every once in a while, I go through the catalog of the merch that's available, and I notice a whole bunch of ladies' tees and other things. I'm like, oh yeah, that's happening. Click, 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 click. So I'm very excited.
So to be clear, it wasn't a conscious choice of us saying no lady sizes. Spring didn't offer them.
For the initial when we first put up the store, they did not have a lot of offerings, and now they have a ton of cool stuff in there now. So
that's awesome. Thank you, Spring.
Thank you for adding that.
Absolutely,
DJ.
Absolutely. We need to up our merch game. We have so many cool ideas for merch, including Tim Ross head on a t-shirt or a coffee mug or something like that.
The word shitbird on just everything. Yeah, I've seen it. The Discord, they want it. The people want it.
Right.
Has the get off my lawn t-shirt idea come and gone? Is that dead now?
Maybe we'll do a Twitter design poll somewhere. Yeah, I still have 80s get off my lawn ACL.
Back when I wasn't Zandy and I used to yell a lot on the show, I was get off my lawn.
Y'all are going to need to fill me in on some of these.
No, let's just,
unless I don't want to be filled in. Just let me know offline.
Awesome. Well, this has been another fun discussion. We might have to come up with a new title for the episode and do data center design, a deeper data center, because there's so much we didn't touch, right? Like, spine leaf, there's just so much that we actually did not get into for data center design. So I would feel guilty calling this a data center design episode. So we'll think of another catchy title and definitely do a data center design episode in the future.
I blame the host.
That's fine. You can.
Not the two of us. It's not me and Andy who don't know.
It's actually probably my fault because I think I took you down so many rabbit holes that
no, I enjoyed it. I enjoyed it a whole lot.
Yeah, me too. Awesome. These are always great discussions. I can't talk to anybody else about this stuff, so thank you for being here and having these talks with me.
Awesome. Yeah. All right. Well, we will see you next time on another episode of the Art of Network Engineering podcast.
Hey there, friends. We hope you enjoyed listening to that episode just as much as we did recording it. If you want to hear more, make sure you subscribe to the show in your favorite podcatcher. You can also give that little bell rascal a little ringy-dingy so you know when we release new episodes. If you're social like we are, you can follow us on Twitter and Instagram. We are at artofneteng. That's Art of NETENG. You can also find us on that weaving web that is the internet at artofnetworkengineering.com. There you'll find our show notes and some blog articles from the hosts, guests, and other friends who just like getting their thoughts down on that virtual paper. Until next time, friends, thanks for listening.